So the first one we're going to do, so there are two types of problems that we need to go over. First one is identifying an unknown metal, which I know I say this a lot, but I think this problem is really fun because it's kind of a mystery. You're trying to determine of the different elements on the periodic table which one this particular metal is, metal M. So in the question, it says 0.126 grams of a metal M, so this could be many different things, reacts with HCl to form hydrogen gas and MCl3. It is found that 7.00 times 10 to the negative 3 mole of hydrogen forms. Calculate the atomic mass of the metal and give the chemical symbol. Okay. So remember that you are taking a stoichiometry test. So all of the questions should require you to do some kind of stoichiometry. Okay, does that make sense? So if you don't do any stoichiometry to answer these questions, something's probably wrong. And if we're doing stoichiometry for these problems, what is the first thing we would need for any problem? Yeah, balanced chemical equation. So for this one, we just have to translate the word problem into a balanced chemical equation. Just make sure this is straight. Okay. So we have metal M reacting with HCl. Right? And then that's going to form hydrogen gas. So what's the formula for hydrogen gas? H2, it's diatomic, so don't forget that. And this compound MCl3. And then we do need to balance it, make sure it's balanced. This one's a little bit weird. I'm going to go a little bit quicker on it, but it might be a little bit of a struggle for you if this were on a test, because you might be tempted to put either a 2 or a 3 here, but you would quickly have a problem. So when you see 2 and 3, a lot of times you just need to find the least common multiple here. So if we put a 6, that will make our lives much easier. So now we have 6 hydrogens here, so we need a 3 here. We have 6 chlorines. We have 3 over here, so we need 2. And then that changes our M, so we need 2M on this side. Okay, so now we have a balanced chemical equation. That's nice. And then you can also start pulling out the important information from the word problem. So it tells us 0.126 grams of metal M, so you can label that here. Is that big enough? All right, and then it also tells us that we have 7.00 times 10 to the negative 3 moles of hydrogen, which is here. Okay, and that's pretty much all it gives us in the problem. And what we're trying to figure out is atomic mass. Of this mystery metal M, right? Well, in order to do that, think about what you know about atomic masses. What are the units of atomic mass? Or molar mass? Atomic mass, molar mass. Grams per mole. Grams per mole, right? Any number that we pull off there is grams per mole, right? So we want, in order to get the atomic mass of M, we want grams of M divided by moles of M. So the setup of this problem comes from your understanding of the units of atomic mass. Okay, so grams of M, do we have that?
Yes.
We do have that. So we have that one already. It's right there, 0.126. Moles of M, do we have that?
No.
No. But what do we have?
Balanced equation and stuff we can do.
Right, we have a balanced chemical equation and we have the moles of hydrogen. So we can get this from our moles of hydrogen using our skills in stoichiometry. So up to this point we haven't done any stoichiometry, but now we're going to use it to figure out the moles of M. So the stoichiometry we are about to do is converting our moles of H2, we are trying to convert that into moles of M. Right, so this is the point in our problem where we're actually doing stoichiometry. Yay. Now you can show off your skills. Okay, so this is a mole-to-mole problem. So how many conversion factors are we going to need? No. One. Just one. Mole to mole, so we just need the mole ratio, right? Right, so we have moles of hydrogen. We need to convert that to moles of M. So moles of hydrogen needs to cancel. We want moles of M. And we get these numbers for the mole ratio from our balanced chemical equation. Right, so it's 2 moles of M and 3 moles of hydrogen. And then remember, when we're typing this into the calculator, 7 times 10 to the negative 3, so we can use the EE button. So 7 EE negative 3 times 2 divided by 3 equals, and then if you want to convert that, sorry, you guys can't really see that. If you want to convert that to scientific notation, remember you can do second 5, and it'll switch it. And then the little number there means times 10 to the negative 3. So we get 4.67, 3 sig figs, times 10 to the negative 3 moles of M. Okay, so that was our stoichiometry step, but we haven't answered the question yet, which is what's the atomic mass and what's the chemical symbol. So now what we can do is just take our original setup for atomic mass, which we know we need grams divided by moles. So now we take our gram amount, and that whole stoichiometry process was to get the mole amount of M. So we put that on the bottom. Again, we can type that in. One, 2, 6 divided by 4.67 EE negative 3. And we want 3 sig figs, so it's 26.98 blah blah blah. So it's going to round to 27.0 grams per mole. So that answers the first part of the question, which was to calculate the atomic mass. We got 27.0. But in order to figure out the chemical symbol, where could we look to figure out what this is?
Periodic table.
The periodic table. So look at your periodic table, and all you're looking for is a mass that is close to 27. So at this point, I'm going to check periodic table. So what element do we think has the atomic mass around 27.0? Aluminum. So the symbol for aluminum is Al. Right, aluminum on here is 26.98, very, very close. And so that is how you identify what the metal actually is using stoichiometry. Did anyone have a hunch that it was aluminum from the very beginning? How did you know that?
Because in the beginning equation it's MCl3, so it had to be something that was plus 3.
Right. So a lot of people look at that and say, oh, it's aluminum. And you're right. Because there are very few metals that it could be with this formula. I will tell you right now on the test, it's not going to be that easy. So you'd have to go through the process. but it's always good to go back and check that it actually makes sense with the formula. So our answer here makes a lot of sense because we know aluminum, when it becomes an ion, has a positive 3 charge. So it makes sense that it would form this compound. Like if you put in Al here, it'd be AlCl3, which is a valid formula. Okay. So that is the first problem. So on a test, it looks like a lot of work, but really all you would need is the balanced chemical equation, the stoichiometry, and then this work here. These steps here in the middle were just me showing you how to set the problem up. Okay. So now that you know how to do it, you can jump from here to stoichiometry to the atomic mass. Okay. So any questions on that one?